Hey guys, this is Mr. Bennett, and this is video 6-2. We're going to introduce acids and bases. So in order to do that, the first thing we need to do is we need to talk about water. And it turns out that really the reason why acids and bases can exist is that water can actually self-ionize itself. In our previous video we talked about ions. We know that there are cations, meaning positive ions, and there are anions, meaning negative ions. And it turns out water can actually ionize itself. It can give itself a charge. Chemically pure water we know has a formula of H2O, right? So if I were to draw that out, we'd have an oxygen atom bonded to two hydrogens, right? What happens is in a typical sample of water is that every once in a while, in fact at a regular pace, water molecules collide. And some of those collisions are just going to be a bump, but some of those collisions are going to have a lot of energy behind them. And in the event that there's a lot of energy behind that bump, there's a possibility that the water molecule could split. So if we look at my water molecule over here, if this gets bumped into hard enough, what will happen is this bond here can break. And it turns out that if you remember back, remember hydrogens have a proton and one electron, right? So very simple atom as far as atoms go. It turns out when that bump happens, oxygen is very electronegative, has a really good attraction for electrons. So this electron that was part of the hydrogen will stick around with oxygen, okay? Because oxygen is very electronegative, it's very attractive to this electron. Meanwhile, this nucleus in the bump gets bumped out. So this hydrogen is going to leave, and it's going to be left as just a hydrogen ion, which is really just a proton, okay? Meanwhile, this oxygen and hydrogen, okay, they're still around, right? They're an OH, but they're also carrying this hydrogen's electron. So they have an extra electron, which means they have a negative charge. Now you may recognize this guy. This is one of our polyatomics that I told you had to memorize last video. It's known as hydroxide. So this is kind of a simple way of showing you that one water molecule can break up. You can get a hydroxide and a hydrogen ion. Now, in my formal or prettier version of this, over here we see the two water molecules, they bump into each other. Hydroxide is over there, okay? It lost its hydrogen, so now it's hydrogen ion, so now it's hydroxide. This hydrogen ion that we've made isn't going to stick around very long, meaning it's going to be attracted by different things. And it turns out water molecules, because of their polar nature, will pick up this hydrogen ion really quickly. So this hydrogen ion is going to get picked up by this water, and this water now carrying an extra positive charge is our other ion over here, the H3O+. Okay, so basically one water molecule loses a proton or a nucleus of a hydrogen, and then the other water molecule takes up that proton or takes that nucleus in. That's going to create two polyatomics, okay, and they are H3O+, which is also known as hydronium, and OH-, which is also known as hydroxide. Now there's a place in your notes to write down both these formulas. Make sure that you do that, okay? And guess what? Hydronium is our 8th polyatomic that you need to know, okay? So it's the 8th polyatomic, and I'm sorry, but you gotta memorize him. He's gonna show up all year long, so learn him now, okay? So this is the 8th one on the list. So now we know water can split, can produce two different ions, hydronium and hydroxide. Now the catch is that when we do the self-ionization of water, so when water actually does split, it's going to split in equal amounts. We said that two waters, right, are going to produce an H3O+ and an OH-, a hydronium and a hydroxide. But they form in equal amounts, right? One of these for one of these. So if we look at pure water, it's going to have equal concentrations of hydronium and hydroxide. In this case, 1 × 10 to the -7th compared to 1 × 10 to the -7th. So since they're present in equal amounts, we call that neutral. Okay, so in other words, when the amount of hydroxide is equal to hydronium, it's neutral. Okay, and it turns out that one of the reasons why it's neutral is that when you have equal amounts, not only are they going to be formed through the self-ionization of water, but if these guys bump into each other, they can actually reverse the process. So if we take a hydronium and we combine it with a hydroxide, okay, this hydronium bumping into this guy will give up that hydrogen ion. And it turns out this negative charge will attract the hydrogen ion, pick it up again, and now we're left with two waters. Right? This water got rid of the proton, so now it's just water, and then this hydroxide picked up the proton, so now it's a water as well. So we get two waters out of it. That's neutral water.